All right, welcome back to the channel. Hope you all are doing well today. Today we're going to be going over some practice problems that will hopefully help you to pass your FE exam. And this is specifically for the civil engineers. So in my last video, we talked about single variable calculus and we went over some practice problems to help you with that. But today we are going through vector operations. So I have a few problems that I think will be good just to kind of refresh your memory on if you are going to be studying for this test and you want to pass this test and you want to have a consistent set of practice problems that you can do every single night. I'm going to be making videos on all of these topics to help ensure that you pass. So you want to make sure that you subscribe to the channel if you have not done so already. All right, so let's get straight into it. And so number one, first practice problem, it says determine the dot product A dot B if A equals 9, 5, negative 4, and 2. So that's a point. And then B, well, that's not a point, it's a line basically. And then B, negative 3, negative 2, 7, and negative 1. So before I do any problem, I always ask myself, can I use the FE manual to help me solve the problem? Well, in this case, I don't know the formula for dot product. So I'm going to go with, let me see if I can search in my FE manual to find or have a formula for dot product. So it's very important that you get used to your manual, your FE manual. And so I'm just going to type in dot product in here. It's only one thing and it comes straight up, right? It says dot product is a scalar product and represents the projection B on to A, right? At times it is given by this formula. And oh, you can't even see that, I'm sorry. So let me make this bigger so that you can see what I'm saying. All right, so it does come up. It says dot product is a scalar product and represents the projection of B onto A. All right, and it says to find dot product, I need to take A dot B. So AX times BX plus AY plus BY plus AZ times BZ and so on and so forth. So I'm just going to take a quick screenshot of this so that you all are able to follow right along with me on this. So let's do it. Let's do it. All right. And hopefully, let's blow this up just a tad so that you can see it. Hopefully you can see that. Okay. So now that we have our formula, let's get to work. So all right, I know that I have my A point. And please don't mind my handwriting. It's been a while since I have used this pen. So negative 4 and 2. And then we have B. There we go. It's starting to look a little bit better. -3, -2. And if you want to speed up this video, feel free. The point is that you do the problem while I'm doing it, so that you get some practice. So I need to do AX BX, right, plus Y BY. Okay. So what is my AX? Well, here's my AX is 9 and my BX is -3. So we're just going to do 9 times -3 plus 5 times my -2, right, plus my -4 times my 7, right, and then plus my 2 times my -1. Okay, so I get -27 minus 10 plus 28, right, and then -2. Okay, so -27 minus 10 plus 28 minus 2, I get -11. -11. And that is my A dot B. So anytime you're doing dot product, you're just gonna normally end up with a plain number unless in the X values they give variables. So hopefully this made sense. Again, sorry for the handwriting. I think I got better at the end, but hopefully this is helpful. All right, let's go to problem number 2. All right, it says between the angle, it says determine the angle between V is 1, 2, 3, and 4, and W is 0, -1, 4, and -2. Let's just get rid of this. So again, every single time I ask myself, is there like some formulas, or can my FE handbook be helpful and useful for this problem? So I'm going to go back to my handbook, and I know that we're doing vectors, right? We're doing vectors, vector operations. So even if you were to type vectors, this would put you in the right place for the problems that you'll be working on. All right. So I see A dot B is equal to, so let's go back to the problem one more time. So we need to determine the angle, right? So I'm going to look for problems that have two vectors that has an angle. And so right now I know A, or that's one vector, that's the other vector. And then I see cosine theta, which is my angle, and then equals a dot product. And we just did a dot product. So we know how to do dot product. We can find the magnitudes. And I think if we can find the magnitudes of our vectors and we can do dot product, then we can probably solve for our angle. So let's try it. All right. Control V. And hopefully this is a good refresher. I think a lot of this stuff was like in Calc 2 or so. That's where it's kind of ringing a bell for me. For those of you who don't know who I am James Huntley, and I've been a civil engineer for about 2 years. So fairly new, got my FE about a year ago. So it took me a while. I failed it I failed it twice. So it's just one of those things that you just got to take the time to really study, lock in, so that you can pass it, so you can start making more money and begin working to get your PE. So I enjoy what I do. It's not bad. I design a lot of plans, do things like that. So work remote. So it's very nice. Very nice. All right, let's get started. So let's first begin by writing the formula that I see. So hopefully this will make a little bit of sense. Hopefully a lot of sense, actually. Drawing tool. All right, so I see. We're gonna try that again. That didn't even look like a A. So the magnitude of A magnitude of B cosine theta is equal to, and we have B dot A. Okay. So how do we get we'll just call V A and we'll say W is B. So how do I get the magnitude of my V, right? Well, let's just do magnitude of V is equal to 1 squared plus so we just have to square all of our X, Y, Z, whatever values for the vector. So, and take the square root of it. Hopefully this is making some sense from prior knowledge. All right. So I struggle doing math in my head, so I'm just going to pull out my calculator. And hopefully you're beating me doing this problem. 16. All right. So I got the square root of 30 for that. All right, what do we get for the magnitude? So we're substituting v for a, so that's that value. Let's try that again. That did not look good. Okay. And then our b value is going to be the same as w, so what's the magnitude of w? We're going to take all those x, y, z values for the vector w. It's going to be the square root of 0 squared. Hopefully you all can see where I'm pulling these numbers from. I promise you, I'm just not pulling them out of my ass. Plus 4 squared minus 2. And it's pretty cool that I'm working through these problems too, because it's bringing back some old memories. Putting me down study lane. Alright, so I got 1 plus 16 plus 4. So hopefully you got is equal to the square root of 21. Hopefully that's what you get. Hopefully I did that right. All right. So now we have our A. So we have this value, our A, and we have our B. We don't know our angle, cosine of theta. But we do know how to do the cross product, right? So the cross product A dot B is equal to, that's just going to be what we just did. 1 times 0 plus 2 times 4. No, I lied. Sorry. 2 times a negative 1. And hopefully you already knew that. Cool. 2 times a negative 1 plus, and then 3 times 4, right? And then plus 4 times a negative 2. All right. And we are coming up almost on 20 minutes. I'm going to have to get faster. But yeah, A dot B is 0 minus 2 plus 12 minus 8. Okay. And I get 2 for A dot B. All right, so now it's just plug and chug, right? I'm going to go ahead and do some quick math, and hopefully this makes sense to you. So theta is equal to, I'm just balancing this equation. So I multiplied my magnitude over, you'll see what I do. You got B dot woo. B dot A divided by A B, and then what I'm gonna do really quick is I'm just gonna move this stuff over. Oh. I don't think I can. I want to let me move. I just want to move it over. Guess I'm gonna have to delete it and try to just write it again. But anyways, I didn't leave enough room. So theta is equal to cosine -1 of all this. All right. So for B is every time you see B, it just is W. It's just, we're just substituting it. So the square root of 21 times I'm sorry. All right. Okay. That is literally A dot B. That screwed me over a little bit. But it's just literally 2, because we found our A dot B, which was 2, over our A magnitude, which is V, so it's square root of 30. And then multiplied by our magnitude of W, which is the square root of 21. All, take the cosine. And this is why it's good to refresh, because these are a lot of steps. So they're not probably going to give you, they may give you something like this, but it may be a quick plug and chug. But if you understand how vectors dot product works, you'll know how to answer the easy stuff. I'm trying to give you stuff that's just going to test you on the principles. 21. All right. Whoa. Cosine. Okay. .079. So. Okay, I actually did get the right answer. So, which that's expected, but felt like my handwriting was so crazy. So that's in degrees. It's 85 degrees, or if you just change your mode to radians, it equals 1.49 radians. All right. I had one more for you all, but I'm not gonna go crazy on time. Looks like I'm already 25 minutes in. So If you like this video, please be sure to hit the like button, share it with as many people as possible. And if you would actually like me to do another problem or do another video specifically on vectors, you can comment that down below, and I'll go ahead and do that last practice problem. I may throw something else in there. So yeah, hopefully this is valuable for you. Don't forget to hit the subscribe button. And for the next thing that the next video that I plan to make will be right under the list of things for the civil section. We'll be going through statistics. So like I said, hopefully this was helpful, and I'll see y'all in the next one. Peace.